Hello everybody, and welcome back to another exciting episode of Tim Time. We have an Icom IC746, not the Pro, just a 746. No turn on. Won't turn on no matter what. I have it on a regulated power supply back there set at 13.74 volts and limiting the current, but as you can see, nothing. So I checked the fuses coming into it, so what I'm going to do is pull the cover off and just kind of follow the power line around. Maybe it's something very visible. So stay tuned while I take the cover off. Okay, took a bunch of screws out of the top, a bunch out of each side, and then you have to take the handle. You have to take the handle off the left side of the radio as you're staring at it. And here comes the top. Now there's another cover on here, so I'll have to take that off as well. That's what the inside of the cover looks like. Yay. Get that out of my way and put my screws in one of my handy dandy screw holders. So you don't have to sit here and watch me run a screwdriver. Okay, raise the camera so now you can look down on it with me. And I haven't really gone over a schematic yet, so I'm not sure what I'll find here. But what I wanted to do is just look inside, and I can see where the 12 volts comes in, a filter board, then it goes back out, then over to here. I do see a fuse here. And that fuse looks to be good. Just kind of looking around at stuff first. See if there's anything in particular that stands out. Alright, so let me poke around and see what we have voltage wise. Oh, that's what I was looking for. It was on the lead already. Alright, so first thing I'm going to look for is battery voltage coming in. 1372 through the filter board. Do we have the same thing? 1372 onto this fuse. So let me I need to throw that onto there. And into the fuse and out of the fuse. 1372. We're good so far. And when I say good so far, I mean it would have probably been better if I didn't have voltage there so far. So I don't see anything that looks terribly burned or anything. Let me turn this off and spin it around a little bit, get a better look around here. And then we'll dig into the schematic. So let's see, you still got a good look here. Alright, nothing looks to be burned up. Okay, let me grab a schematic and we'll see what's going on. Okay, now to get caught up in the Icom. So I think when last I was recording, we were looking for voltage and we had the supply voltage coming in and going across this fuse. And then it went into the radio, and where did it go from there? Who knows? I did find this IC1, which is a voltage regulator, and it has the 14 volts coming from the fuse. This is the fuse inside now, not the main fuses that are on the wire. This is inside on the PA board. Everything up to that was good. So I came down here and I found this and I checked this. I do have 14 volts in and about 5 volts out. So we know that's good. Now if you follow this, this goes all the way over to the next page. That's what makes it tough with this particular setup, is the way they have this schematic broken up into pieces like this. So we know we have that. Now I wanted to check for the other regulators, and there's one here and there's one here. And if you look, they get their input, they're both together. Here's one here, comes an input, and if you kind of look, it's tied through, comes over here through this little resistor and into the input of that one. There's no 14 volts on this line, nothing. So where does it come from? Well, right here, and I'm hoping you can see my arrow, right here, these two lines coming in, the 14 volts comes through these two chokes here, one and one. They're just in parallel, probably just to keep RF out of your signal, or out of your supply voltage, or any kind of noise for that matter. So let's see, these both go up here. So remember this line right here, it's kind of right across. I'm going to try and go down, and if you look, it comes to this little relay. Well, I don't know if it's little, to this relay that's still on the PA board. And I was able to find all these parts, and I'll be able to show you, but it's too hard to take the camera because I have to move around so much with this darn schematic. So here it is. The 14 volts is here. So where does it get its 14 from? Well, it comes over this way, and then it goes down, down, and if you follow it, it goes to another page. But if you follow the contactor for the relay and follow that down, that goes right to the 14 volt fuse right there. So that's where it gets its 14 volts. So the question is, what energizes this relay? Well, here's the coil. And if you follow this around, this 14 volts from the fuse straight around, where's it go? Boop, right down here to the coil. So really all we have to do is supply a return or a ground or a common to this coil, and it should suck shut, putting 14 volts on this line and energizing both of these regulators. Now, easier said than done. This little guy here is what controls that, and it would get its voltage from somewhere else. PWRS, I believe, is what that says. And if you look, power on, 4 volts, off, 0 volts. Well, I always have 0. Of course, it won't turn on, so that might explain that. So anyhow, I followed it, and it went, and it came here. So when you come here, when you come to this page, if it's on the right, you know it's going to be down below it. So let's just see. PWRS, but then when you get over here, it's PPWS or something, but it's still the same thing. So where does that get its power from? It goes to the main unit. And sometimes you can be thrown off by these. This doesn't necessarily mean that it's getting 14 volts just because it's attached to this line that goes up there. It's just showing you that that line comes down to the connector, but not necessarily this pin. So don't get thrown off by that. So we have to go to the main unit and find J1331, 2PA unit. So it's page 111. If you look down here, you find the PPWS, still no 14 volts or no 4 volts or whatever I'm supposed to have. There's no voltage. We're assuming it's going to be around 4 volts just because of what the other thing said. Comes down here into a multi-line, goes across, and if you take my word for it, so that we don't have to keep doing this, it goes into main unit 2, so not 3. And if you look here, you'll see it's this main unit 2 here. Yeah, okay. Okay, see, here's PPWS. I knew I thought it changed somewhere. Now it becomes PWRS. I was right on that other board, so now I just have to remember where I found that at. Where the voltage comes in. Let's find PWRS. Right here, PWRS. So it's telling me now, they're giving me a direction. They're saying that it comes out of here and goes where it has to go. So we kind of know that because that's the control voltage for the relay. Well, that's the control voltage to the transistor that controls the relay. So, let's follow and see where PWRS is. Okay, this video is kind of broke up into pieces. I'm not sure how far I got before, how far I'll get before something else comes up that I can't get back to the radio. But anyhow, I think I might have shown you before this actual Zener diode here that was actually on the board, and it looked like it might have suffered some type of catastrophic explosion. Not too bad, but it does have a crack in it, and doesn't seem to be working. So here, right here, coming into it, this line down here should be about 14 volts from the power supply. And the output, actually, that's a comparator circuit. I'm a little confused by the whole thing too. I have to do a little bit more research on it. But the output should have 5 volts from the, I think they call it the 5HV circuit. It's weird that they would draw that like a voltage regulator. You figure they probably had some other thing they could draw it like. But that part number, if you look that up, that S8054ALB, Alpha Lima Bravo, that is a voltage comparator. And they say it's in power supplies, and how it actually works, I'm not too sure. So I don't want to get too in-depth into it, but a couple of things I wanted to check to see why that Zener would blow out. So the first thing I wanted to do was make sure that we do have 14 volts here, or some kind of supply voltage here. On this side where we should have 5.6, it's only a like a 200 milliwatt Zener. I want to see what the resistance on the other side is. Should be kind of high resistance, because I would think 5.6 volts. You wouldn't want too much current going through there, because it would heat up and break the Zener. But there's really not too many components other than that comparator, a resistor, and a capacitor. And then I want to see if there is 5 volts on the O side of the comparator. This is kind of crazy to try and follow this through, because like I've showed you before, these are all on different pages. So let's see, that ends there, which means it will be on this page here. Right there. So we'll do a couple. I'll show you what I'm testing. We'll do a couple tests and calculate some things. I don't know where. Let me see if I get a calculator open if we need it. I don't have. No, I got a phone down here. I could use that as well. But let's get a calculator. Just in case we need it, I like to have that hanging around on the desktop. Alright, so, well, the first thing we're going to do, I'm curious why that Zener would blow up. So it's a 5.6 Zener, so we're assuming it's something after 5.6, so we're just going to say 5.6 volts on it. And let's see, 5.6 volts. And let's see how many ohms. I'm going to test right here on the input. I gotta go back to the other drawing. So I'm going to test the output of the Zener, which is the input. So I'm going to test right about here. And let's see. I don't know, I'll shine down so you can watch me on the meter. Alrighty. So let's check. This will be the output side of that zener. So it'll actually be the anode side of the zener to ground. About 150 ohms. That's kind of what I was thinking, was maybe low resistance. So let's see, we'll do the calculation with 150 ohms. Let's see, try to get my arm out of the way of the... So 5.6 volts and 150 ohms divided by, poop, I didn't want to do that. Let's try that again, clear. We'll go 5.6 divided by 150. Tells us we have basically 37 milliamps. Let's see, 37.33 milliamps. So if we did 37.33 milliamps times the voltage times 5.6, that would give us the power. And that's saying it looks like 200 milliwatts, if that's correct. That's still a little bit overboard. It seems like it will be higher than that. Alright, either way, let's see. Alright, so still a little bit over the rating of the zener, if that would be correct. And that was just kind of rule of thumb. That wasn't really a very good calculation. But if that zener's only rated at 200 milliwatts, we're a little bit over it. So that would explain why it failed and why it didn't like blow apart, failed, but just kind of looks like it overheated. So let's see. What I'm going to do now is put voltage to the radio. And I'm going to check to make sure that we have 14 volts coming into that. And then I want to look at what kind of voltage we have on the comparator. So let me put some voltage to this. Red. Come on. And where is the black wire? Some install it. What the heck? That's crazy. I gotta take my glasses off so I can see what I'm doing here. That sounds nuts. I gotta take my glasses off so I can see what I'm doing. Alright, that one goes up there. This one goes around here. Where does it go? Oh, it's clipped back there. I thought it was sitting out. Alright, I'm going to stick this on and see. Hopefully we won't see any smoke. Alright. Now, let's see. Let me check out the volts here. DC volts. So this would be the input to the zener diode that I'm going to test now. 13.72 volts. Sounds about right. Double check the output. Zip. Good. Okay. Well, not good, but what I expected. So now we're going to go down to that. You still see the meter? Can't tell. Let's see. In case you didn't see it, there's the input to the zener, 13.72, and then the output was 0. So let's see if we have anything down at that comparator. This has 3 leads on it. One's going to be a ground, one's going to be an input, one's going to be an output. So first lead, I see 0. Middle lead, 0. Other lead, 0. Okay. What was that? Now I would have kind of thought that maybe we'd see 5 volts on one of these. The reason I'm thinking that is because the H5V or 5HV, I think it gets its power from the 5-volt voltage regulator that's on the other side of the radio. And I thought we checked that one and it was good, but I'm going to have to go back and double check on that. Or with my probing I've destroyed something. So let's see. I want to check the, take the power away and just make sure that the thing doesn't turn on. Yeah, I want to take the power away and check the resistance on all of those other leads of that doohickey. So let me remove the power. Go back to ohms. So now, if my calculations are correct, out of the 3 leads, one's going to be ground, so it's going to have almost 0 ohms. One's going to be the same as the Zener diode, that we're around 150 ohms, because they're connected together. Then the last one is going to be the one that goes to the other stuff on the board. So let's see what we get here. Checking on the end here. About a little less than 1 ohm. That's probably the ground. There's about the 150. That's probably the come on. That's probably the one that goes to the Zener, and then the one on the end. Ooh, 19 ohms. That doesn't sound right. 18 ohms. That sounds even worse. I mean, I'm going by the assumption 18 ohms doesn't sound right. So let's see, where does that go? So let me get my calculator out of the way. And I'm going to zoom you back up to that. Alright, now we have to go down because we can't see what's happening here. Well, I can. I'll tell you what happens here. The output comes over this way, goes up, and it goes to these 3 lines here. 1, 2, 3. And I'll just show you real quick when you go down here and look. Did I go the wrong way? Yeah, I went the wrong way. Let's see. No, that should be. They would be on the next page at the beginning of the note because I didn't have it slid over there. So here we are. So if you see, they come in, they're out of here, they go up to a resistor, a 1K. So regardless of what's happening, unless something's wrong with this, I should have at least 1,000 ohms between that device and ground. Because think about it, if a piece of wire fell to ground and it was on this side of the 1K, I'd have at least 1K. Down here we already have a ground, that's 100K. So if a piece of wire were to fall right here, you know, to ground, then I'd have low resistance, or fell to something else. So either this resistor failed, or both of them failed. But then you get up to other things, because even if that one failed, this one here, there's another 1K resistor, but it hits 2 capacitors, so all DC is done at that point. There's no more testing going on here. Unless this resistor failed, and these shorted. Again, not too likely. Come up to here, this resistor failed, probably not too likely. So wait, we got this line here. That could have failed, and maybe it's going across this line. Let's see where that one goes. So I need to go up. That'd be the middle line. So it's this line. Okay, the resistor over there failed, and we came to a diode here, and the diode shorted, and went up to the processor, and the processor shorted. So all those things could have happened as well. Or something happened internal to this guy here, and it's making the connection from output to ground. So let me see if I can find this regular diode here and see if we can check it in circuit, at least get an idea of what's going on. I'll look for it, give me a minute. Okay, and as you can see, the high quality of this schematic, your guess is as good as mine. Alright, I believe this right here is our Zener that's blown up. Wait, am I right? No, maybe not, hang on. No, this is our Zener here that's blown up. This guy here. This is the voltage comparator that I was referring to. And remember the 1000 ohm and the 10,000 ohm resistor I was talking about? One went to ground and one continued on. Then there was a Zener, or I mean a regular diode, and I think this thing here may be it. So let me see if I can, still got no power on it, let me see if I can get some leads done on there. It is a very, very tiny component. So let's see what happens. Remember, it's in circuit, so I don't really know how much we're going to get from this. Okay, I'm showing what, 1.4, 1.5 volts. I don't know if that's see when I just touch my leads together, I get 0. So let's see. Again, there's no voltage to the radio. So looks like possibly that the cathode would be on the left. Maybe? I don't know. Alright, so I switched the leads, now I'm going to try it on the other side. And 0.59, so that could be a diode. That way 0.6, and then the other way, the only reason I'm getting some kind of reading at all is because it's still completely in circuit. But that component behaves kind of like a diode, where when I have the leads one way, I get a voltage reading, or a reading, and when I switch them the other way, I get a different reading. Whereas if it was a resistor or a capacitor, you would expect I'd get the same reading. It's okay. Looks like probably that's a diode, and probably it's okay. So my question now is, should there be voltage on one side of that diode? Perhaps. Let me, I'm going to put voltage back to the radio, and in the really bad schematics, nothing here. However, I got 5 volts here. Well, let's see. The higher voltage on this side would cause current to flow this way. So we know since there's a 0 here right now and we have 5 here, it's not going to flow that way. So it's kind of like this is acting like a check valve right now, but we do have 5 volts here, which tells me that everything on this side is okay. So we know we have 5 volts coming from the PA board to there. So the problem seems to be something between there and the voltage comparator. So that's probably where I'm going to stop, because now I want to do a little more research and find out about what that voltage comparator actually is and how it works in this particular application. I'm turning everything back off. And where in the heck can I get one, or a reasonable facsimile thereof? Now I'm not really an electronics person, even though I did stay at a Holiday Inn Express last night. This is kind of a hobby for me, so I'm not going to pretend I know all these answers. And especially, my knowledge lied back in the vacuum tube days. And then I learned Kenwoods just because I worked on them all the time. This is something completely new, because not only is it a different brand of radio, but it's also basically computer controlled. It's a computer for all practical purposes. So I have to learn a whole different way of playing with things on these very small current and very small voltage devices. I'm used to being able to kind of brute force things into working, and it seems like when I do it on this kind of stuff like computers and whatnot, I teach myself a lesson. An expensive one, albeit. But for all you youngsters out there that are starting down this path, don't be afraid to experiment. Get out there and do stuff. Build stuff. You're going to blow a lot of crap up. You're going to break a lot of stuff. I think they told me I could break an iron ball. I'm trying to turn this on. Okay, let's see if it works. I'll show you the components that I was referring to before I sign off for the night, for the day, or what? I can't even see. Oh, okay, this is the background. Oh, okay, it's going to work. Let me take the lid off, and let me click OK to this. Let me find what I'm looking for so you can see it. All right, this guy right here. Excuse me, I know it's a little bit dirty. This guy right here is the voltage comparator. Pretty sure that I showed you already the there's the Zener diode with the hole blown in it. See that thing right to the right of it that looks like it says A? Well, I see it does have a black stripe on it. That is that diode that I just checked. To give you an idea, that's one of my test leads. So I'm going to put my test lead next to the diode. It just gets on there. Okay, so that's it. What else did we have to show you? Well, if you follow that, I don't know if I can keep it in focus the whole time, from that Zener diode, you can almost see the trace comes all the way over this way, and then it's going to go into, where is it? One of these guys here. I believe it's that one. You can see it's all scratched up for me trying to get a lead on it. But that's the inductors that they use probably to keep the noise out. But then that comes over to, yeah, that comes over to the ribbon cable, and that ribbon cable goes back up to the PA board. So we have 14 volts to that on the PA board, and then we have the 5 volts coming in. So my thought is that the voltage comparator needs a closer look, and of course the Zener diode needs replaced. The Zener, I know that they're going to be hard to find. I even saw that like an equivalent was the NTE. There's something a little easier to look at. The equivalent was the NTE diode, and it's no longer available. So I think I did find them on eBay, but you know, you hate to get some of that stuff because you don't really know if it's a cheap knockoff or something. But I guess when I have nowhere else to turn to get these items, I may end up going there. So anyhow, that's where I'm going to end the video today. And if any of you people have ever run into anything like this or have any good ideas or solutions, be sure to post them. I know I don't always get back to my posts right away. Like I said, I only do this as a hobby, and half the times I post a video and I forget to even check and see if there's any comments. And then I do, and it's 3-4 days later. So I do what I can. Anyhow, I hope you enjoyed, and I hope you're at least seeing things maybe that if you have a similar radio and maybe it's something you've worked on or you want to work on, hey, don't be afraid to break it. I told you, my video could be entitled Things Not to Do. So thanks for watching, and I'll update you as soon as I find something.